Nigel Letherby, Training Manager for Paratech Incorporated. Today we're going to go over the collapse rescue for advanced rakers and shores. This is not a PowerPoint. This PowerPoint presentation is for informational purposes only. It is not a substitute for hands-on training taught by a qualified instructor. Regular hands-on training is necessary to become proficient. Improper use of any of equipment may cause serious injury or death. Think safe, act safe, be safe. Collapse rescue. Gravity is your enemy. Buildings are always under constant stress. Building structural elements and connections make up its gravity resistance system. Gravity never sleeps. Basically, when you're at a collapsed building, the building is always moving around, and the building always wants to go to ground until it can't move anymore. Application of forces. There are three types of forces in structural collapse. Compression, which basically you're pushing together. Tension, which you're pulling apart. And shear, where material joined together is pushing and pulling, causing a shear stress on the joining material or on the single piece of material. Diagram shows a beam under stress, showing the beam under both compression and tension. If you take a look at the top of the beam is under compression. You've got a neutral plane in the center, and the bottom of the beam then is under tension. It's just pushing away. Double funnel principle. This is the foundation for all shoring. The header collects the load. The post supports the load, which is your Paratech, your 4x4, your 6x6, and the sole plate distributes the load. So in essence, if you've got a spot shore, the top collecting load is 3 feet of 4x4. To support the load, which is the post, which is the Paratech, or the 4x4, or the 6x6, distribute the load on the spot shore is basically your 4x4 at 3 feet long to distribute the load over a number of beams. Shoring classifications, we got a class 1, a class 2, and a class 3. Class 1 is a temporary one-dimensional shore. It's got no lateral bracing or stability. Basically, that's your T-spot or your spot shore. The class 2 is the shore with at least 2 posts that are cross-braced together. Double T, horizontal, window door shores. That's your class 2. Class 3 is a 3-dimensional shore. This goes to your lace post, your rakers, your slope floor shores. Class 3 are the strongest and most stable shoring systems. We'll be covering mostly class 3 today with your advanced rakers. So rakers, if you take a look at the picture on the left, we got the one on the top is the flying raker system that's cross-braced with wood. The top right is the absolute raker, where your raker is under 11 feet, so we got 2 lateral braces and 1 diagonal. Bottom left is your double raker. That's got double X on the double, plus on the internal it's got a single X with lateral bracing. Then your one on the bottom right is your midpoint brace raker system. It's got a midpoint brace coming from the bottom of the rail up to the center of the raker, and that one's also double X'd. If you take a look at the different capacities we've got here on the right table on your right hand side, this was test was done with David Hammond, which is the structural specialist engineer for FEMA. Bruce Miller, he was an independent engineer. George Roxton, William Teach, which is Bill Teach, they are our engineers in Paratech. Myself, Ken Nielsen, who owns Paratech, and Hans, who is the sales officer. If you take a look at some of the angles and calculate the load on those angles with the different systems, your regular wooden 4x4 raker system gives you 4,000 pound per leg. So on a system, it gives you an 8,000 pound on the system. Flying rakers are not really recognized because they are such a temporary shore, but On a flying rake out of wood, it gives you 1,000 pounds per leg. If you take a look at our flying rake at 45 degrees, it's got the angled calculated load, which is 55,000 pounds. So that flying raker will give you 55,000 pounds at the angle on the calculated load at 45 degrees. The absolute raker system with braces on the front will give you 46,000 pounds calculated angle load. Why that is a little bit different from your flying raker to your absolute raker system is because that absolute raker system has not got the midpoint brace set in place. If the midpoint brace was set in place, it'd be a little higher. The double raker system that you see on the bottom left, the calculated angle load on that is 54,000 pounds. That's for both rakers, the internal and the external, to give you the double raker. Going back to your absolute raker system with the midpoint brace on the raker, that one gives you 68,750 pounds on your calculated angled load. The recommended load safety factor is 4:1 with Paratech. So if you take a look at the different calculations we've got on the bottom table with the angled calculated load, it drops it down to 13,000 on the flying raker. Still going to be 46,000 on the absolute raker, but you're going to divide that by 4, gives you 11,000 without the midpoint brace system in. The double raker gives you 13,500, and the absolute raker with the midpoint brace system gives you 17,188 pounds. That's 4:1 safety. Structural claps, you see the double raker system, the absolute double raker system, I should say, on your right-hand side. And that's how it's made out of the braces. We've got the 4 laterals on the outside with 3 diagonals. On the inside, we got 2 laterals with 1 diagonal. This one's a 60-degree raker. So my internal shore is under 11 feet on the internal raker. The external raker, my shore is around about 22 feet on that raker system itself. The insertion points are about 8 or 9 feet on the internal and about 18 feet on the external. If you take a look at the table on the left-hand side, that shows you how to build a wooden double raker system. That wooden double raker system that goes up, as you see, is a lot of work, there's a lot of nails, plus you'll most probably be splicing your wall plate, which in essence weakens the raker a little ways. Again, we got a couple of different notes here. The one on the left gives you the degrees that you're going to calculate to give you the wooden raker. On the Paratech raker system, we've got a cheat sheet that exists on the rail itself that does all that work for you. But your 45-degree raker, you take your insertion point, example 10 feet, you multiply it by 17, gives me 170 inches. That's the length of my raker for a 45-degree 10-foot insertion wooden raker. If I want to do the calculation with a 60 degrees, then I multiply my insertion by 14. Will give me 140-inch raker at 60 degrees. On the right, we've got some designed loads for some different wood posts. If you take a look at the bottom, this is all out of the FEMA guide. So a design post for a 4x4 at 8 foot long is 8,000 pounds. 6x6 is at 12 foot long is 20,000 pounds, and so on and so forth. This is just here so you can come back and take a look at some of the different capacities we've got on the wood in compared to your Paratech raker that's made out of aluminum.
Hello, I'm Nigel Letherby, training manager for Paratech Incorporated. Today we're going to do a video on the double raker system. Here I've basically got one leg and all the braces to do the raker. The raker is going to be at an 18-foot insertion and approximately a 9-foot insertion for the bottom raker. So here I've got the raker rails for the one leg. I've got the latch bases, 12 by 12 base plates. I've got a junction base, a rail junction base, 2 splices for the rails, 2 L brackets. I got my 610 struts. I got a 406 strut, 2 6-foot extensions, 1 4-foot extensions, 2 1-foot extensions. I've got 10 B57s, and I've got 1 B23 as one of my braces. Also, I've got 6 or 7 of the 2-foot extensions, so I can put my braces together in the span that we need. Also, for the whole raker system, you're going to need 20 clamp and clevis bases, so we can put the braces on both outside raker and inside raker. The rope, we got a rope and a carabiner. We need that to hold the raker up in place because it's going to be long and it's going to be heavy. Okay, so the first part of the procedure for putting a double raker together is connecting all the rails. So when you take the rails in place, we can use 3 6-foot rails on this. Hang on. Next, we're going to put the latch bases and a rail junction in for the insertion heights we need. The first latch base is going to go at the base for my sole strut for my inner raker. Then I'm going to count up 10 holes. 1, 2, 4, 5, 6, 7, 8, 9, 10. At the 10th hole, I'm going to put my rail junction in. Then I'm going to count up another 8 holes, which is my last hole for my last latch base. When that's in place, I'm going to start building my outside raker and my inside raker. My outside raker is going to require 2 6-foot extensions plus 1 610 strut. This is the only time you're going to put 2 gold extensions together to build this double raker. I'll lift it up, hands. Then we're going to put our 12 by 12 base plate on the end. When you do that, make sure that the anchor ring points away from the wall. Next, we're going to build our inside using a 435 and a 610 strut. Because we're building a 60-degree raker, my base is going to end up with One 12-inch extension and a 435 strut. For that, I need to come out around about 70 inches. There we go. Put my 12 by 12 plate on. Next, we're going to come in with our B23 with a 1 foot extension. B23 is going to go into your rail junction. Give it a spin, make sure it's locked. Make sure your brace is at about 90 degrees.
Yeah.
And all that can be adjusted when it's in place. My 2 feet are a little bit close together, so what I'm going to do is I'm going to adjust my B23 out a little ways. Beautiful. Now we are ready to put it up into place. Okay, now we carried the raker into place. Now it has to be raised. We're a little bit limited because there's only 3 of us here, but we should be able to get it into place with relatively ease. We've attached the rope to the raker rail at the top. So as we lift, the other rascal will give us help with the rope, get it into place, then we can adjust it. Okay.
Full Andrew, go out there and pull. Set your pole.
Okay, now the 2 raker legs are in place. The next thing to do is cross brace. We're going to start with the inside smaller raker cross bracing. We're going to put 2 lateral braces on and 1 diagonal. Okay, now the inside raker is braced. Now we need to brace the outside raker, then pin the raker to the wall. We can use different things to pin the raker rails to the wall depending on the structure. On a double raker like this, you're going to need at least 4 pins in the wall. Range anywhere from 1/2 inch rebar, 3/4 rebar, or lag bolts depending on construction. Also, concrete anchors can be used. You can drill through the rails, through the holes of the rails into the concrete, anchor it to the wall.
The corner raker, there is no real data or pictures on a wooden corner raker because you cannot make it out of wood. The reason being is because it's perpendicular to 2 walls, there is no straight surface where you can actually nail a 2x6 brace. or laterals or horizontals onto that corner raker. Because we're using clamp and clevises and aluminum braces, as you can take a look there, we can cross brace, lateral brace, diagonal brace the corner raker on the Paratech system. Again, you're going to go to the strength of the raker on the leg itself, with the table I showed you earlier, with a regular flying raker or a regular solid sole raker or a regular split sole raker. That's going to be your strengths on the corner raker. Corner raker now, you can just follow the raker up the wall either side to strengthen the whole building. But that protects the corner, and that's what it's for, is to protect that corner so you can and you are able to shore up both sides of the building if need to.
Hello, I'm Nigel Letherby with Paratech Incorporated. We're here to put up a corner raker. For the corner raker, we're going to put up 2 flying rakers and cross brace them. The components we got here, we're going to use an 8-foot insertion at a 60 degrees. Components I got for one leg would be a 6-foot rail, one 610 strut, one 235 extension, one B23 brace, 2 latch base cups, 1 clamp and clevis, and 1 base plate. We're going to mirror each side on the corner. We'll measure for the cross bracing and put the cross bracing on. We use a corner raker. Basically, if the corner of the building is compromised, where we can put one on one side, one on the other side, coming down to capture that corner. And once that corner is captured, you can build off each side if you need to. Okay, we got our 6-foot rail, and we got a cheat sheet on the rail that gives us the length of the strut per insertion. I'm using the 60-degree table at the bottom. My insertion height is 8 feet. I come across, it tells me I need a 9-foot raker for the 60 degree. So, first thing I'm going to come in, I'm going to put my cup in for my insertion. Then I'm going to count down 3 holes. 1, 2, 3. Then my cup goes in the 4th. That way, that gives me a 60-degree raker. If I were to put my cup in the 3rd hole, then that would give me a 45-degree raker. So, 60 degree down the bottom. I'll bring it on its side. I'm going to put my 2-foot extension in. I'm going to come in with a 610. I'm going to place my B23 in the bottom cup. Make sure it's in. I'll make sure my screw is all the way in. I'll bring my clamp and clevis, lift up my strut, bring the brace in. Make sure my brace is 90 degrees to the rail. Like I said, I need a 9-foot rake. So I've got 8-foot and 2-foot. A 6-foot and 2-foot, sorry, gives me 8 feet. I'll bring my thread out for approximately a foot. Put my base plate on. Anchor ring goes away from the wall. My flying raker is ready to go into position. Okay, now we've set the raker and put it all together. It's time to put it into place. Take it right up, Hans, right up. Okay, we'll take a look at the insertion points. insertion points look pretty good. There we go, it's a bit better. Then we can put our pickets in. Then we make sure the rail's tight against the wall. My head is in. I'll adjust my brace for my flying raker. Make sure the bottom of the rail makes contact. Then we can come in and measure our braces. Okay, now we're going to come in and measure for the braces. For the bottom one, I'm going to need about an 8-foot brace. For the top one, I'm going to need about a 4-foot brace. Then my diagonal is going to be around about another 8 feet. So we're going to come in with the first brace. So the top brace is going to go in. Going to go as close as you can to the corner. And my last brace is going to go in. And there's our corner raker.
Class 3 Type 2 slope floor. It's one of the harder shores to build out of wood in a collapsed building. The reason is, if you take a look at the picture on the left-hand side on this Type 2, it's a lot of work involved. Now they are saying that you can build this inside the building, and you're going to build it in place. It's virtually impossible to build this on the outside, bring it into place it up, and there's just no room to do it. Problem is with the wooden slope floor shore is the measurements are critical of where you need to be on the slope of your header and your sole plate. The measurement on the legs are critical as well, because if you don't do the measurement correctly, then you'll be padding out 1 or 2 legs with wedges and whatever to make up the distance between your header and the floor that's collapsed that you're trying to support. If you take a look on the right, this is a Paratech slope floor. Again, it's got the braces on. Now, with the braces, if you take a look at the back of that shore, we've got 2 lateral braces on there and 1 diagonal. You can also do that on the front. That's just going to strengthen that shore up and stop those legs from moving around. We've got diagonals on all 4 sides. The diagonals are there. You're going to follow suit with the diagonals going the same way around that shore. That way, when you look through any part of that shore, you'll see an X. On the Paratech shore, we need to pad out each leg if using a raker rail. The raker rails are gold, and as you see, we're using the raker rails here. So if we're using a raker rail, we need to pad out the bottom of every basically vertical shore with 3 pieces of 2x6, 18 inches long, exactly like the wooden one on the left-hand side. That way, that shore then will be tab data on that shore will be there. You're not relying on the raker rail to carry any weight or anything like that. The raker rail will just keep the shore together. Then you're going to anchor both bottom and top of the show itself. So you're going to pin through or bolt through the rail on the top of the slope floor show going up to the collapsed floor. Then you're going to pin the bottom rail attached to the floor. You can put whalers behind the plates, behind the raker rails at the back, then drive pickets in. Or you can also, where the red arrow shows at the back of that show, where I've got a cup, a latch base in there, holding that horizontal. If I put junction bases in there, your raker junction bases, then I can take a show from there and put it back to a load-bearing wall on both sides, and that will hold the show in place.
Hello, I'm Nigel Letherby, training manager for Paratech Incorporated. Here today to go over the slope floor. It's the hardest show to do instructional claps. If you take a look, we've got one leg already in place, and I'm going to go over the components I need for the other leg. I've got two 6-foot raker rails. I've got one 406, one 304, a 1-foot extension, a B23, two latch bases, and a clamp and clevis. Basically, we're going to mirror the other side, but the brace has got to go in the opposite direction. So as we look through the shore, you actually see an X brace. So what we're going to do with this is, the maximum you can be apart on shores is 4 feet. So basically we're going to build a 4-foot box. When the two legs are in place, we're going to cross brace the back, then cross brace the front. It makes a complete box on your slope floor. You're ready to rock and roll to hold the floor from collapsing. Okay, now to assemble the slope floor show. The front of the slope, I'm going to put the two cups. Make sure you put the rails next to each other so you can marry and make the two rails identical. Then I'm going to count up 4 holes. 1, 2, 3, 4. I'm going to put the other 2 cups in. That gives me 4 foot apart per shore. The next thing is going to come in is going to be my 36 to 50 inch gold shore. Then my 406 with a 1-foot extension on. And grab the 1-foot extension behind it. Grab the 1-foot extension behind it. Right there. We're going to lay the shore over. Put the cups in. Then we're going to carry into place. I've already measured where the shore needs to be, so it's 4 foot away from the other one. Line it up. You push it in a little bit. Okay. I'll drag this back a little ways. A little bit too far. Okay, right there. Then we bring it up into place. Then we need to pick at the base, just so it stops it from moving around. Then we can readjust the front and the back as needed. Then we put our B23 plus a 2-foot extension. Now the diagonal needs to go opposite, so that one needs to go on the bottom. When it goes on hand, slide it as far down as it'll go. Yep, perfect. With that in place, now what we're going to do is we're going to cross brace the front and the back, doing the same, using the same braces in the front and the back. So whenever you look through the shore, no matter what side you look through, you see an X brace looking through. To further strengthen the shore, you can put lateral braces on, top and bottom, front and back, and that'll strengthen that shore up, which is not going to go anywhere. Remember, the shore's got to be pinned to the ceiling it's holding and to the ground in the back. Stop it from sliding out. Okay, now with the front braced and the back braced, that completes our slope floor. Like I said earlier, we could put laterals down the bottom and at the top, down the bottom and at the top if we need to give it more stability. But your shore's in place, everything's tight, and this one's a little bit off, but we're not building cabinets. Your slope of your floor could be off, so it may be at different angles. But with that, the braces compensate for that. We can twist the brace at a different angle to compensate for the angles of the floor, of the floor that's collapsed and the floor it's resting on. Now, going back to using raker rails. Because the raker rail is not a tabulated data rail, unlike the whaler, you can use the whaler for this as well. It doesn't make a difference. But if you use the raker rail, then you've got to pad out each foot. Pad out the foot with 3 pieces of 2x6, cut 18 inches long, put together under each foot. And that makes your raker rail strengthened at the point of contact and compression, what your shores are going to take for the load.
High strength shore. If you take a look at the high strength shore, it's basically, it was also known as a column base, a column shore. Column shore was there. If you take a look at the picture on the left, we've got 2 in place holding up that structure, that beam. That's there if your columns, your concrete columns have been compromised. We'll put the column base or the high strength shore base in place. We've got 2 there going up because of the span of that concrete header, or the concrete header that's there that's holding the floor. We put 2 in place. We can also put another one there if we wanted to. The high strength shore design load is based on the length of the struts in the table. This one is at around about 12'6", I'd like to say. So if you take a look at each shore at 12 feet, at 4-to-1, I'm at 10,000 pound per shore. So I'm at 30,000 pound per shore on the one on the left and the one on the right. It's the same picture, just closer. If I can drop that down to a 2-to-1 safety factor on that, then I'm at 20,000 pound per shore at a 12-foot insertion. Gives me a 60,000 pound shore. So utilizing the 2 shores at 2-to-1 gives me a 120,000 pound system at a 2-to-1 safety factor. If you take a look at just below the hose insertion on the shores themselves, I've got a center brace on there. That center brace had stability and capacity to that shore. Example, we did exactly the same shore doing a test in California with FEMA, and they put the shore in the machine. At 92,000 pound, we broke their machine. Their bottom plate deflected and broke the machine. So we were only able to take the shore up to 92,000 pound. We could not take it to failure, of which I guess we will do that in the future, because we would also like to know the failure of the shore with that center brace in place. Remember, we can add 2 braces if we wanted to cut up the length of the shore itself. As it is, that one has cut up that shore by about half. So I've got under 8 feet on both sections. So it gives me nearly full capacity on that shore. Here I put some tabulated data in here from the FEMA fog guide. This just gives me, the one on the left, just give me some symbols that you may come up against going into a collapsed building, where they may mark out what they need in the building, going back to your T-shore, your double T, your vertical 3-post, your V3, lace post. cribbing, raker shows, horizontal shows, or your window and door. On the right hand side, I put this in place so it gives you a little bit of reference on the weight of materials you'll be supporting. Your normal reinforced concrete is 150 pound per cubic foot. Structural steel is 490 pound per cubic foot. Aluminum, 165 pound per cubic foot. So on and so forth with that. Quick weight estimation at the bottom. It's just there for reference. Thank you. And I hope you enjoyed this webinar. And I hope you enjoyed the 3 videos that we put together with what we did with your advanced raker and shows.